So let's say that x is equal to t plus 2, and also y, let's say that's equal to t squared, and t is between -2 and +2. So the best way to graph this particular equations is to make a table with three variables, t, x, and y. So the t values that we're going to use is going to vary from -2 to 2. So now let's find the x values at the given t values. So t plus 2 is equal to x. So if we plug in -2 into t, we can see that x is going to be 0. If we plug in -1, -1 plus 2, that's 1. And if we plug in 0, 0 plus 2 is 2. And then you get the pattern. It's simply going to increase by 1. Now let's do the same for the y values. So we know that t squared is equal to y. So if we plug in -2, y is going to be 4. If we plug in -1, -1 squared is +1. 0 squared is simply 0. 1 squared and 2 squared, we're going to get the same numbers, 1 and 4. So once you complete the table, now you can go ahead and graph it. So let's plot the points. So the first point is at 0, 4. X is 0 and y is 4. The next one is at 1, 1. We just got to plot the x and y values. Don't worry about t for now. And then we have the point 2, 0. And then 3, 1. And finally 4, 4. So now we can graph it. And so that's the shape of the graph. The first point is t equals 0. The second point, t equals 1. And here t is 2 and 3 and 4. Now you want to draw an arrow indicating the direction of the curve. So basically, you want to draw it in a direction from a low t value towards a high t value. So it's going in that direction. And that's how you can graph a set of parametric equations. Now let's work on another example. So let's say that x is equal to the square root of t, and also y, let's say it's 3t plus 1. Go ahead and graph it within this range from -2 to 2. Feel free to pause the video and try this example yourself. Let's modify this equation a bit. Let's say t is equal to or greater than 0. So let's try that problem. So we're going to choose 0, 1, 4, and 9. The reason why I've chose those values is because we have the square root of t. So I want to use perfect squares. So let's start with x. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. Now let's find the y values. If we plug in 0, y is going to equal 1. And if we plug in 1, it's going to be 4. Next, we need to plug in a t value of 4. If we do so, 3 times 4 is 12, plus 1, that's 13. And then we need to plug a t value of 9. 3 times 9 is 27, plus 1, so that's 28, which is too large to graph, so we're not going to worry about graphing that point. The majority of the graph is in quadrant 1. We don't need too many x values, but we do need a lot of y values. So if we plot the first point, 0, 1, that's going to be here. That's the y-intercept. And then 1, 4. And then 2, 13 is probably as far as we can graph it. So this graph appears to be going in that direction. So here t is 0, t is 1, and t is 2. And so we can see the general shape of the graph. Let's say that x is equal to 2t minus 4, and also y is equal to 4t squared. Sometimes you may need to graph this particular parametric equations by eliminating the parameter. So what that means is that you want to get y in terms of x and then graph it. How can we do that? Well, let's start with the first equation. X is equal to 2t minus 4. What I like to do is solve for t in that equation. So let's add 4 to both sides. So x plus 4 is equal to 2t. And then let's divide both sides by 2. So x plus 4 divided by 2 is equal to t. Now what we're going to do is replace t in this equation with x plus 4 over 2. And that's how we can get y in terms of x. Now this is t squared, so we have to square x plus 4 over 2 squared. 2 squared is 4. And on top we have x plus 4 squared. 4 divided by 4 is 1, so we can get rid of those two. Therefore, we have this function, y is equal to x plus 4 squared. So how can we graph this particular equation? Well, if we have the graph y equals x squared, the parent function looks like this. So, given the graph x plus 4 squared, we can graph it using transformations. The graph is going to shift 4 units to the left, and everything else is going to be the same. Now, the last thing we need to figure out is the direction. We know that x is equal to 2t minus 4. So therefore, as t increases in value, x increases in value. So this graph is going in this direction. When t is 0, x is negative 4. So t is equal to 0 at this point. When t is 1, x is negative 2. So which is this point. So that's t equals 1. And as you can see, t is increasing as you travel towards the right. Let's work on another example. Let's say that x is equal to the square root of t, and y is t minus 1. So let's eliminate the parameter. The first equation, let's square both sides. So x squared is equal to t. And let's replace t with x squared. So we can see that y is equal to x squared minus 1. Now this graph looks like the same graph as x squared, but it shifted 1 unit down. So it's going to look something like this. However, this is not the answer that we want because we have a restricted domain. T cannot be negative because it's inside the square root. So t has to be greater than 0 or equal to it, which means that x is equal to or greater than 0. So therefore, we only have the right side of the graph. You can confirm this by making a table. So the lowest t value we have to start with is 0. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. Now let's use this equation. 0 minus 1 is negative 1. 1 minus 1 is 0. 4 minus 1 is 3. 9 minus 1 is 8. So the first point that we need to plot is 0, negative 1. That's the y-intercept. Now the next point that we need to plot is 1, 0, which is here. And then after that, we need to plot 2, 3. And we're not going to plot 3, 8. It's too far. So we can see the graph is going in this direction. So here t is 0, and then we have t equals 1, and for this point t equals 2. Let's say that x is equal to 3 sine t, and y is equal to 3 cosine t. And let's say t is between 0 and 2 pi. Eliminate the parameter and graph the equation. Now for this particular problem, it's helpful to know that sine squared plus cosine squared is equal to 1. Using this equation will make it a lot easier. Now let's solve for sine in this equation. If x is equal to 3 sine t, then sine t is x divided by 3. And cosine t is going to be y divided by 3, based on the equations we were given. So sine squared is x over 3 squared, and cosine squared is y over 3 squared. So then what we have is x squared over 9 plus y squared over 9 which is equal to 1. Now, if we multiply everything by 9, x squared over 9 times 9, the 9's cancel, so you're just going to get x squared. The same thing is going to happen to y squared over 9, and 1 times 9 is 9. So what we have is basically the equation of a circle in the form x squared plus y squared is equal to r squared. So we have a circle centered at the origin with a radius of 3. So that's the shape of the graph. Now what we need to do at this point is indicate the arrows. So to do that, let's make a table. And we said that x is equal to 2 sine t. So let's start with that equation. And keep in mind t is between 0 and 2 pi. So let's choose some common points like 0, pi over 2, pi, 3 pi over 2, and 2 pi. Sine of 0 is 0, sine pi is 0, and sine 2 pi is 0. Sine pi over 2 is 1 times 2, that's positive 2, and this is supposed to be 3 pi over 2, by the way. I forgot the 2 there. Sine 3 pi over 2 is negative 1 times 2, that's negative 2. Now let's move on to the other one. Actually, this is supposed to be a 3. I'm making too many mistakes here. So that's 3 and negative 3. We said that y was 3 cosine t. Cosine pi over 2 is 0, and cosine 3 pi over 2 is also 0. Now cosine of 0 is 1 times 3, which is going to be 3. Cosine 2 pi is also 1 times 3, which will give us 3. Cosine pi is negative 1, so this is going to be negative 3. So t is equal to 0 at 0, 3. And then pi over 2 occurs at 3, 0, which is here. 0, negative 3 is at pi. 3 pi over 2 is negative 3, 0. And 2 pi is back at 0, 3. So clearly we can see that the arrows should be traveling in a clockwise direction. And so that's it for this problem. Let's try a similar problem, but somewhat different. Let's say x is equal to 3 plus 2 cosine t, and also y is equal to negative 1 plus 2 sine t, and t is still going to be between 0 and 2 pi. So what do you think we need to do in this problem? Go ahead and try it. So just like the last problem, we're going to isolate cosine and sine. In the first equation, we need to subtract both sides by 3. And then we need to divide both sides by 2. So therefore, x minus 3 divided by 2 is equal to cosine t. On the right side, we need to add 1 to both sides. And then we'll divide both sides by 2. So y plus 1 divided by 2 is sine t. Once you isolate cosine and sine, then start with this equation. Cosine squared plus sine squared is equal to 1. So cosine, we know it's x minus 3 over 2. So cosine squared is x minus 3 over 2 squared. And sine is going to be y plus 1 over 2. And let's square it. So what we have now is x minus 3 squared divided by 4 plus y plus 1 squared over 4. And that's equal to 1. Now let's multiply everything by 4. So this is going to be x minus 3 squared plus y plus 1 squared, which is equal to 4. This is the equation of a circle, the standard equation, when the center is not at the origin. Here's the standard formula, x minus h squared plus y minus k squared, and that's equal to r squared, where the center is h comma k. So what is the center for this particular circle? Since it's x minus 3, it's going to be positive 3. And here we have y plus 1, so it's going to be negative 1. That's the center. And the radius, we need to take the square root of 4, so the radius is 2. Now we can go ahead and graph it. So first, let's plot the center, which is at 3, negative 1. And then using the radius, let's get the other 4 points. Let's travel 2 units up, 2 units to the right, 2 to the left, and 2 units down, starting from the center. Let's do that again. Okay, my drawing is not perfect, but you get the picture. That's the circle that we have. Now, what we need to do is determine, should the arrows be pointing in the clockwise direction or the counterclockwise direction? So let's make a table to find out. So we're going to have t, x, and y. Now, we said that t is between 0 and 2 pi. So we're going to choose 0, pi over 2, pi, 3 pi divided by 2, and 2 pi. Now, we said that x is equal to 3 plus 2 cosine t. So if we plug in 0, cosine of 0 is 1, and 1 times 2 is 2, 3 plus 2 is 5. Now, if we plug in pi over 2 into cosine pi over 2 is 0, 0 times 2 is 0, 0 plus 3 is 3. Now, cosine pi is negative 1 times 2, that's negative 2, plus 3, 3 plus negative 2 is 1. Cosine 3 pi over 2 is 0, and 0 plus 3 is just 3. Cosine 2 pi is 1 times 2, that's 2, plus 3 is 5. Now, let's move on to the other one. Y is equal to negative 1 plus 2 sine t. So let's start by replacing t with 0. Sine of 0 is 0. And so negative 1 plus 0 is just negative 1. Sine of pi over 2 is 1 times 2. That's 2. 2 plus negative 1 is 1. Sine of pi is 0. 0 plus negative 1 is negative 1. Sine of 3 pi over 2 is negative 1 times 2. That's negative 2 plus negative 1. So that's negative 3. And then finally, sine of 2 pi is 0. So it's 0 plus negative 1, which is negative 1. So now, let's find out where the t values are. Let's start with 0. T is 0 at the point 5, negative 1. So this point is 5, negative 1. So that's where t is 0. Now, t is equal to pi over 2 at 3, positive 1. So that's over here. And then t is equal to pi at 1, negative 1. And then 3 pi over 2 is going to be at 3, negative 3. And 2 pi is back at 5, negative 1. So t is increasing in the counterclockwise direction. So it's in the opposite direction compared to the last problem. And the best way to figure out the direction is to use a table with 3 variables, t, x, and y. So based on what you know, you can do this problem. It's a little bit different from the last one, but there are some similarities. So let's say x is equal to 3 cosine t, and y is 4 sine t, and t, as usual, is between 0 and 2 pi. So how is this question different from the last one? Well, just like before, let's isolate cosine and sine. So x divided by 3 is cosine t, and y divided by 4 is equal to sine of t. So starting with this expression, cosine squared plus sine squared is equal to 1. We have that x divided by 3 squared plus y divided by, okay, that doesn't look like a y, so let's rewrite that. Y divided by 4 squared is equal to 1. So notice that this is not the equation of a circle. So we're not going to multiply both sides by 9 or 16. We're just going to leave it the way it is. Because these two numbers are different, this is an ellipse. If they were the same, it would be a circle. So now, how do we graph an ellipse? So let me rewrite this. The general equation for an ellipse in this form is going to be x squared over b squared plus y squared over a squared, which is equal to 1. A is the large number. If 9 is equal to b squared, that means b is 3, and the square root of 16 is 4, so a is 4. Now, there's no h or k values, so therefore this particular ellipse is centered at the origin. B is 3, and b is associated with the x variable, so we got to travel 3 units to the right on the x-axis and 3 to the left relative to the center. A is 4, so we got to go up 4 units and also down 4 units. And now let's go ahead and graph it. So that's how you can plot this particular ellipse. Now let's make a table. And let's use the same values for t. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now, x we set is equal to 3 cosine t. Cosine 0 is 1, so times 3, that's 3. Cosine pi over 2 is 0. Cosine 3 pi over 2 is 0. Cosine pi is negative 1 times 3, that's negative 3. Cosine 2 pi is 1 times 3, so that's positive 3. And y, we set it equal to 4 sine t. Sine of 0 is 0. Sine of pi and 2 pi is also 0. Sine pi over 2 is 1 times 4. We have positive 4. And sine 3 pi over 2 is negative 1 times 4. That's negative 4. So when t is 0, we have the point 3 comma 0, which is here. And when t is pi over 2, this is going to be 0, 4. And then negative 3, 0 is when t is pi. And then 0, negative 4 occurs when t is 3 pi over 2. And then here, this is 2 pi again. So we can see that t is increasing in the counterclockwise direction. That is, the direction opposite to a clock. Let's graph one more equation. Let's say that x is equal to 2 raised to the t, and y is equal to 2 raised to the negative t. And t is equal to or greater than 0. Go ahead and plot it. And also, eliminate the parameter. Now, let's eliminate the parameter first. ln x is equal to ln 2 raised to the t. Whenever you have a variable on top, the best thing to do is to take the natural log of both sides. And this will allow you to take the variable and move it here. Our goal is to solve for t. That's how we can eliminate the parameter. So ln x is equal to t ln 2. And dividing both sides by ln 2, we can see that t is ln x over ln 2. The base of the natural log is e, but we can use the change of base formula. For example, log ab is equal to log b divided by log a with a new base, in this case base c. Base c is like base e, so we need to go back this way. We could eliminate the natural log function and use the regular log. So ln base e of x over ln base e of 2 is equal to ln, or we could just use log base 2 of x. Anytime the base is not e, you have to use a regular log function. If the base is e, then it becomes a natural log. So what you need to realize is that ln x over ln 2 is equivalent to log base 2 of x. So now what we're going to do is replace this t with log base 2 of x. So y is equal to 2 raised to the negative log base 2 of x. And this is like a negative 1, which we can move it back to the exponent position, the same way we brought this t in front. So therefore, y is equal to 2 log base 2 x to the minus 1. Now what is this equal to? The fact that these two numbers are the same, they will cancel, and it turns out that the answer is simply x to the minus 1, which is 1 over x. So that's the equation in terms of x and y. The graph of 1 over x looks like this. However, we have a restricted domain, so we only need a portion of this graph. So let's make a table. So x is 2 raised to the t. And we're going to plug in values starting with 0. 2 to the 0 is 1, 2 to the 1 is 2, 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16. Now y is 2 raised to the negative t. 2 to the negative 0 is 2 to the 0, which is 1. 2 to the negative 1 is the same as 1 over 2, so this is a half. 2 to the negative 2 to the negative 2 is 1/4. 2 to the negative 3 is 1/8, and this is going to be 1 over 16, based on the pattern that we see. Now let's go ahead and plot it. So starting with t equals 0, we have the point 1, 1. So the point 1, 1 is right here. Next we have 2 comma 1/2, which is about that much, and then 4 1/4, which is somewhere over here. So basically the graph is going towards the x-axis. So this is the original 1 over x graph, and all we have is simply just this portion of the graph. So t is equal to 0 at this point. Therefore, the arrow is going in this direction. And so that's it for this particular problem. So we've talked about eliminating the parameter t. But what about doing the opposite? What about adding the parameter t to an equation? So for example, let's say that y is equal to 3x plus 5. How can we write an equation with x in terms of t and y in terms of t? A quick and simple method is simply to replace x with t. So you could say t is equal to x, therefore y is 3t plus 5. You could do it that way, but it's like, what's the point? Because these two appear the same. So let's change it. Instead of doing that, I mean, you could do it and still get the answer right. Let's replace the entire 3x with t. So we're going to say t is equal to 3x. Therefore, y is going to be, replace 3x with t, it's going to be t plus 5. That's a nice and simple way to turn this equation into a parametric equation. Let's try another example. So let's say if y is equal to 2x minus 8. What's t and what's y? That means t is going to be equal to 2x. And if you want to isolate x, that means x is t over 2. Technically, this is the one that we need. And so y is t minus 8. So we need these two equations. This one, we got to solve for x. So x is t over 3. So these are the two equations that we want in the first example.